Yeah, just 6 Fs. Since this is an exploration, we're not going to start off with our I can statement like we normally do, because we're going to kind of explore and figure out what our I can statement is today, right? But our learning target today is 2.2.4. All right, so here are our rules. Some of these apply more for virtual versus in person. You are working independently. Obviously, this is normally like a group activity, but 2020 is weird, so we're working by ourselves. But you are trying your best. Even if you aren't 100% sure how to do something, I just ask that you try. You are being courteous to your classmates. So this is one of those things that probably applies more to virtual people than in person. But I know that everybody processes at a different speed. So we're just making sure that you're not throwing answers in the chat right away. You're giving everybody time to think and to process. Be respectful of that think time. And then the last thing I want to remind you of is that I'm going to ask for observations. And when I ask for observations, they're just things you notice. So there are really no wrong answers when I ask for observations, because you can't be wrong about things you notice, right? So without further ado, let's get going here. For number 1 on your paper, hopefully you have this paper. If not, don't worry about drawing all the grid lines. You can just kind of sketch your axes and the little tick marks. I'm going to give everybody about 2-ish minutes here to go through and to graph both of those equations on the graph. Graph both of those lines. My reminder to you is to use the Y-intercept first and then use the slope to guide you. Okay, and then there are 2 questions about what do you notice about the lines themselves, and then what do you notice about the equations of the lines. So don't throw answers in yet. I will ask for answers to those questions, but I'll give you about 2 minutes here to graph both of those lines and make some observations. Virtual people, I will be right back. I'm just going to do a lap around the class here. Oh, yeah. Good. All right, so we're graphing here. You remember we have to pick out our slope and our y-intercept. So what you want to start with the b. So looking at that first equation, what's the b? So you put it down to 2. And then you're going to use your slope to guide you. So since it's 1/3, how are you going to move? A little louder, can you hear me, sir? Yeah, and then you go over 3, so go up 1 and then to the right 3, and put it back. Good. You should be finishing up about graphing those lines. And then I will be calling on somebody, so make sure you're ready with an answer. You're ready to give me an explanation here. Did you figure it out? I just called you Ben. I'm sorry. So you have to pick out the m and the b. You remember in y equals mx plus b. So m is going to be 1/3, and that's your slope. And then b is going to be 2, and b is the y-intercept. And that's what you're going to start with. So since b is 2 on your graph, you're going to put it out at 2. Sense? Yeah, the y-axis. And then your slope tells you how to move. So 1/3. Yeah, there you go. Good job. And then follow the same process for the second equation. All right, let's hear from Gabrielle. Can you turn on your mic and tell me how to graph either one of these equations? I don't care which one.
I didn't finish it.
That's okay. We can work through it.
Okay.
Which one do you want to do?
The first one.
The first one. Okay, where would I put my first dot?
Oh, at the 2 and then
Mm-hmm.
the rise over run, so go over down 3 and over 1.
Oop, I think you got it a little bit mixed up. Remember, it's rise over run. So if it's 1 over 3,
Oh.
what's my rise if it's rise over run?
1.
Uh-huh. And since it's positive, we're going to go up 1 and then over 3. Does that make sense, Gabrielle?
Yeah.
Awesome. And we put our dot here. You can turn off your mic. Thank you. And then we're connecting our dots to make our line. So you guys should have lines that look like something like this on my board right now. And then the second equation. Oh, no. What did Miss Carr mess up? Yeah, Caitlin, thank you. I messed up. It should have been at positive 2. Silly me. Thank you for calling me out on it. Even your math teacher makes mistakes here. Our second equation is at negative 4. So there we put a dot at negative 4, and then we still go up 1 and over 3. And it looks like this. All right, now hopefully you guys were able to make some observations, and I'd like to hear from both my in-class and my virtual people. So let's start off with, what do we notice about our lines? What do you guys notice about our lines here? Yeah. Yes, for those of you that couldn't hear, we said in class that they are parallel. Okay. For my virtual people, do you guys know what parallel means? Ah, beautifully said, Evelyn. The main thing is that they will never intersect. So this you're going to see a little bit more in geometry as well. But because those arrows, we can keep drawing those arrows. And no matter how long we drew these lines for, they're never actually going to cross each other. Okay, they're just going to keep kind of running alongside of each other. What about their slopes? Did anybody, oh, I just kind of gave it away. Did anybody make any notes about the equations here? Yeah, thank you. I kind of gave that one away. Do you guys see this thing about the slopes? What do you guys notice? Yeah. So both my virtual and my in-person people have decided that the slopes are the same. If we look here, I have a 1/3 for my slope here and a 1/3 for my slope here. So I could say m equals 1/3 in both cases. Okay, but let's talk about B. B is 2 in our first equation, but 4 in our second equation. Emery, stay with me. Okay, so our slopes are the same. What about our y-intercepts? Are those the same? Our slopes are the same. Are our y-intercepts the same, guys? No, they're not. They're different. We have 2 and 4 here. So for parallel lines, your slopes are going to be the same, but you will have different y-intercepts. All right, so if you are writing this down, this is an important thing to write down if you're on a blank sheet of paper. Give everybody about 10 more seconds, and then we'll move on to our next slide. Thank you guys for bearing with me. I know that we have to go at a little bit different pace when we're including everybody, so I appreciate it. Remember, my virtual people, if you have any questions, don't be afraid to throw them in the chat or to just turn on your mic real quick. Geez, oh, Pete, you are right, Caitlin. Miss Carr is making mistakes all over the place. The y-intercept would be -4. Thank you for calling me on it. All right, let's go to this next frame. Okay, now I want you guys to try about the same thing. We're going to graph both of these lines, but this is a little bit different. You're going to have to kind of rearrange this top equation. Think back to what we did last week. Now it's not in y equals mx plus b form, so you're going to have to solve for y first. Remember, use your SAD map and get y all by itself first, and then graph both of those equations, right? So again, I'll give you about 2 minutes here. I'm going to do a lap, and then I'll be right back. Virtual people, be ready. I'm going to call on somebody. I don't know if it's in class or virtual, so be ready. Okay. All right, so for that second one, that first equation, you have to get y all by itself. Do you know how to do that? So what would you want to move first? So how would you do that? Since it's negative, what's the opposite of being negative? Positive, so you're going to add x to the side. Yeah. Did you hear me on that? Okay. How do we do that, Marie? Okay, you got the second one. The first one you have to rearrange a little bit. So you have to get it to look like y equals mx plus b. So remember, we do SAD map. So is anything being added or subtracted to your y? If it's a minus x, how do you get rid of that? Yeah, add x on both sides. There you go. And then there's one more thing you'll have to get rid of on that side. How are you doing, ma'am? Look at you. Checking in. How are we doing over here? All right, so I'm going to rewrite this. And we have to get y all by itself. So, Chardonnay, can you turn on your mic and walk me through how I would solve for y here?
Are we on the second one?
We're on the number 2. We're doing this first equation. You're getting y all by itself.
Yeah, okay.
I need it to look like y equals mx plus b.
So you would do like plus x to 8.
Good. I'm going to add x on both sides. And did you guys get at least here? Okay, then we'd get x plus 8, because remember, we always write the x first. Then what's the last thing I have to do, Chardonnay?
You're gonna divide it by 4, both sides by 4.
Beautifully said. So I'm going to divide everything by 4. So what would my final answer be here? It's a little bit tricky.
Would it be 2?
We're going to have a 2 at the end. What about this term? That's the one that looks a little bit funky.
Would it be 4x?
Close. I got you. All right, you can turn off your mic. I'm going to explain it. So here, since there's an invisible 1 and 4 does not go into 1, we're just going to leave it as a fraction. So we would just leave it as 1/4 x. You guys see how I did that? Do we see how I did that? Do you guys see how I did that? All right, so now we're graphing both of these, and this is something we should be pretty familiar with. Let's make sure let's try and make no mistakes this time, Ms. Carr. We're going to put a dot at +2, and then I'm going to go up 1 and over 1, 2, 3, 4. That's my slope. And draw my line. Boom. And then I'm going to do the same thing for the second equation, but I'm going to start at -3. And then I'm going to go up 1 and over 1, 2, 3, 4 again. And I'm going to draw my line. And so even though these were given to us in different formats, again, what are we noticing here? What do you notice about those lines, people? Yeah, thank you. I got it in the chat and in person. We said that they're still parallel. Even though they didn't originally look like it, once we rearranged it, after solving for y, we noticed that they had the same slope. Okay, so once we rearranged it a little bit, then it was just like question 1. Then we were looking at our m and our b, and we noticed, hey, our m is the same. I'm going to pause here in case there are questions. Do you guys have questions? Let me know. All right, cool. It looks like I can go on to the next frame then, which is our conclusion. So I'm actually going to skip number 3, and I'm just going to go, because I think we've talked about it enough, I'm going to go directly to the class conclusion. That for parallel lines, sorry, brain fart, parallel lines, we said have the same slope. But remind me, did they have the same y-intercept? No, they do not. So we can say parallel lines have the same slope, but different y-intercepts. So the m needs to be the same. The b can be different. Okay, and I know you guys know what parallel lines look like, but this is the important thing for algebra. So if you're writing this down on a separate sheet of paper, make sure you just got what I starred written down. All right, now then I want you, going off of this rule, I want you to try and write an equation that would be parallel to what I've just underlined, that y equals 6x plus 9. Okay, try and write your own equation for something that would be parallel. And since we're all writing our own equations, yours might be a little bit different than your neighbor's or than somebody else's in the class. Remember, our rule says the slope has to stay the same, the y-intercept cannot. So try and write your own equation. Be right back. So our slope has to stay the same. So what's our slope in that equation? Looking at the y equals 6x plus 9, what's the slope in that equation? What? You don't have to solve anything. No? You're coming up with your own equation. So just looking at that, out of the 6 or the 9, which one's your slope? Yeah, the 9 is your y-intercept. So when you write your own equation, the only thing that has to stay the same is that y equals 6x. You can have whatever number you want in.
So this would be the same thing to change this?
Yeah, that's it. Uh-huh. How do we do? Sure, that works, yeah.
I just have the numbers switched.
You guys are doing great. Ooh, Evelyn, you guys can't see what she asked. She just asked, what would the lines be called if they had the same slope and the same y-intercept? So if they were exactly the same, they're just the same line, and it's what we call coinciding. That's the like fancy term for it. But we're not going to focus on that in algebra. You will run into things where sometimes they are exactly the same. But I really just need you guys to know parallel and our next term that we'll see in a second. But coinciding is if it's exactly the same. Good question. Do I have a volunteer that wants to share their equation, what they did? You can be in person or virtual, any equation. Emery, give me your equation. What'd you write down again? I knew you had it. Good. Okay, so this is just an example of something that could be parallel. You'll notice that Emery kept the same slope. The only thing we've changed here is our 9 has now become a -2. And literally, you could write any number there that you want. The only thing that has to stay the same is a 6. So if I wanted to put like plus 10,000, go for it. Okay, it's technically parallel. The only thing that matters is that the 6x stays the same. Feeling good? Can I get a good, bad, from virtual? Tell me good, bad, in person. Can you give me a thumbs up, thumbs down? Okay, I'll take it. I'll take it. Yes, you could, Caitlin, getting fancy with it. Evelyn, thank you for telling me you're feeling okay. What about the rest of our virtual people? How are we feeling? Connor, thank you. All right. If you have the actual paper in front of you, we are flipping to the other side. If you don't have the actual paper with you, you're just kind of continuing to write. So on the other side here. Now, I'm not going to break it down problem by problem again. Instead, I'm just going to give you guys like a full 2.5 minutes to go through and to solve both problems number 5 and problem number 6. And you're really just graphing those 4 lines and making observations about them. And these are going to look a little bit different than the first 2. That's okay. These are going to intersect. But I want you to make observations about specifically how they're intersecting. And then also, again, pay attention to those equations. See what you notice there. So I'm going to have 5 up on the screen. That's the first question. And then if you don't have the paper in front of you, to see number 6, you can pull up the Jamboard and just go to the next frame. But I'll give you guys 2.5 minutes to graph all 4 of these equations and try and make some observations. And then I'll ask for some of them. Okay? Remember, if something isn't a fraction, how do you make it into a fraction? Yeah, put a 1 under it. So for that very first equation, you're going to have to put a 1 underneath that -2 for your slope. I'll be right back. I'm not forgetting about you. Good job. It looks like you got the first. In number 5, you graphed the second equation correctly, but that first equation, the y equals -2x minus 1, like we messed up a little. So you plotted it at -1. That was good. Then what's your slope? -2 over 1. So -2, that tells you how much to go up or down. I think you did, yeah, I think you did run over rise instead of rise over run. Does that make sense, Emery? Nope, if there's only one number, you throw a 1 under it. And so you'll either go up or down, depending on if it's positive or negative, and then you always just go 1 to the right.
What if it's negative?
Nope, you always go to the right. The negative just tells you that you're going down. Does that make sense? I'm doing over here, ladies. So you put a dot at negative. Oh, you're so close. Look at that slope. It's -2. So instead of going up 2 over 1, you gotta go down 2. What do you do? Down 2, and then you have to go over 1. Remember, if it's not a fraction, we have to make it into 1. So you were right, go down 2, and then just go over 1 as well. And then put a dot right there. Yeah. There you go. Your Jamboard won't work? Oh. Uh-oh. Here, I'll flip to the second one for a second so you can write down your equations. It might just be because so many people are on it right now that it's freaking out. All right, while we're doing that, Adelphine, can you turn on your mic and tell me how to graph one of these equations? I don't care which one.
I did y equals negative.
This one?
Yeah.
Sorry, which one? The negative 2x?
2x minus 1. I put -1, the points on -1, and I went down 1/2.
Ooh, are you sure?
Because they were negative over. Oh, I went up 1.
Look at our slope. If we have -2/1, this is our rise. This is our run. So that top number tells me if I'm going up or down. So looking at that number, how much am I going to go up or down?
2.
And are we going to go up or down?
Up.
If we have a negative?
I said we're going to go down 2/1.
There we go. You got it. Just took a second. There you go. Awesome. So now we got one line. Our other line, I'm just going to plot this one quick. We start at 3, and then we go up 1/2. If there are any questions, please feel free to ask. Okay. So now I got my 2 lines, and I already told you guys that they intersect. But do we notice anything specifically about how they intersect? That's an anybody question. Do we notice anything about how they intersect specifically? Yeah, thank you, Caitlin. For those of you that can't see, Caitlin said that they make a 90-degree angle. So if we look at our graphs when they cross, we do have these 90 degrees. We can represent that with a square. That's kind of a geometry notation, but you guys can just get one up on geometry here. So we know that they make 90 degrees. Do you guys know what that's called if things intersect and make 90-degree angles? There's a fancy term for it. I feel like I might have seen this on your paper, Brianna. Do you know what it's called when they intersect and make 90-degree angles? No? Oh, I thought I saw it on your paper. Oh, yeah, Connor and Evelyn, thank you. These are what we call perpendicular lines. Okay, so these are perpendicular, and we know that they cross and make 90-degree angles. Okay, so that's our other big word today. We got parallel. The second one we got is perpendicular. Stick with me, Emery. Okay, now that we know our second big word, I want to go back. Our first equation had a slope of -2/1. Our second equation had a slope of 1/2. What do you guys notice about these two slopes? They're very similar, but they have some differences. What do you guys notice? Look at our two slopes. Oh, geez, how did that just happen? Oh no, I messed it all up. There we go. That's pretty good. Do you guys notice anything about the slopes? Thank you, Evelyn. I see what you wrote. Look at our two slopes right here. How are those different from each other? Yeah.
Well, one was higher than another one, and originally I don't know how to say it.
No, you're right. You're right. You're on the right track. So Evelyn and, oh, look at that word you're pulling out there, Caitlin. Beautiful. So Evelyn and Brianna, you both said something similar here. Yes, the first thing we notice is that one of these is negative, the other one is positive. Okay, so what the first thing that's happened is that the signs change. So when we want to make a perpendicular slope, you first have to change the sign, meaning that if it was negative, it becomes positive. And then if it was positive, it becomes negative. And this is the other really big important thing that you're going to want to make sure to write down today. Okay, so the first thing we would do if I want to write a perpendicular slope, I'm going to change the sign. The second thing that both of you noticed as well is that we are going to flip the numbers. Okay, so really quick, just this is not anything to do with this problem. I just want to practice that. So let's say I have a slope of 3/4. Okay, Damari, can you turn on your mic and following these two rules that I have over here, tell me what my new slope would be.
Like on the ground.
Just, this is not anything to do with the graph. This is separate. So I'm looking at this slope, the one that I've just boxed off, and following these two rules. If I wanted to make a new slope, what would my perpendicular slope look like? Following the rules that say change the sign and flip the numbers.
Flip the numbers. It wouldn't be 4/3.
We'd have 4/3. And what else? It would change from positive to
Negative.
Negative, okay? Good, thank you. So that's an example of a perpendicular slope. You have to follow those two steps. Are there questions on that, ladies and gentlemen? That was just an example. And then the fancy word, Caitlin, you were close to that. The fancy word here is the they're opposite reciprocals. If you want to know the fancy word, I just care that you know how to do it. But if you wanted to know, it's either opposite reciprocals or negative reciprocals. So you were very close with that term, yeah. All right, so again here, we have a case. Now that we kind of see that rule, again here we have a case where we have our slopes. Eunice, can you tell me the slope of this first one? Or the slope of both of them, actually?
The first one is 0 to.
Yeah. For those of you that couldn't hear, she said, well, I wrote it down. Okay, so we have our two slopes here. So literally just by looking at that, I don't even have to graph this. Now that I know the rules that say that you flip and you change the sign, I can literally look at our two slopes and just based on that say these lines are going to be perpendicular. And if you want to double check that, you can graph. But now that we know the rules, you don't even need to graph. You can just look at the equation. Okay. How about perpendicular? Can I get a thumbs up, thumbs down, or a good, bad, if you're a virtual? In class, thumbs up, thumbs down. How are we feeling? Okay. Let's go through one more example because I'm getting some S's, and I want to make sure that we leave here feeling good. Right? So I'm just going to kind of come up with this on the spot. Here we go. Let's say I have y equals 5/6 x plus 8. Okay, that's my equation. And this is like something I would give you on an assessment. I would give you the equation, and then I would ask you to write one equation that is parallel and one equation that is perpendicular. Okay, so we go back to our rules. We know if we scroll back, if I need a parallel slope, the rule we said was that they have the same slope, okay, but they have different y-intercepts. Again, all we really care about is the slope. The y-intercepts can change. But parallel lines, they have to have the same slope. So I'm going to write that down so I remember. So parallel, we know they need the same slope. If you're writing this at home, this is not on your notes. This is an additional example. So you guys can just write it on a blank space on your notes or wherever. I think maybe the back is blank. I'm not 100% sure. And then perpendicular, we just went over that. There were 2 steps. The first thing was to change the sign. The second step was to flip the numbers. Okay, and again, we really only care about the slopes. The y-intercept do not matter at all. Okay, so I'll give everybody about 30 seconds here using both of those rules to try and come up with a parallel equation and a perpendicular equation. Okay, remember the slopes are the only ones that matter. You can use whatever y-intercept you want, right? I'll be right back, virtual people. You are working to come up with those 2 equations. So yeah, you guys can just, this isn't on your notes, you can just kind of write it somewhere separate. Yeah, that works. Did you come up with an equation for it? Oh, you need a pencil. That's hard to read through all that marker. Oh my goodness. Did you come up with an equation? So in that first one, look, we just have to keep the same slope. Look at our equation that I gave you. What's the slope in that equation? Remember, slope is like m, which means the m. Yeah, 5/6. So in your new equation, it needs to have that same slope, 5/6. But you can change that last number to be whatever you want. All right, I'm back. Connor, can you turn on your mic and give me a parallel equation? What did you come up with an equation that is parallel to that example I gave you?
Y equals x plus 99 and y equals x plus 100.
Oh, you came up with your own set of parallel equations. I see what you did. Can you come up with an equation that would be parallel to the example I gave up here?
Oh, yeah. Y equals 5x plus 99.
Ooh, double check that slope. What should our slope be?
Oh, yeah, 5/6.
There you go. Plus 99, and I love that you just picked a random number. Again, the slope is the only thing that matters. The y-intercept is not. For perpendicular, do I have a volunteer, somebody that wants to give me their perpendicular equation? You can be virtual or in person, I don't care. Look at our 2 steps that we have to follow. You guys are quiet today. Caitlin, can you give me your perpendicular equation?
It'd be y equals -65x plus 9.
Beautiful. Thank you, ma'am. So here we changed it from positive to negative. Are you guys following? We changed it from positive to negative, and we flipped the 5 and the 6. Do you see that? And then again, that second number, I don't care what it is. It could be minus 1,000,000. It could be plus 1,000,000. The only thing that matters is the slope. All right, what questions do we have over today's lesson? Now we have our I can statement that says I can, given a linear equation, create an equation that is parallel and an equation that is perpendicular. So that's what we worked on today. Are there any questions? Do you guys have any questions?